Hello everyone, myself Mukund Ramprasad Soni. I am student of Arihant College of Education. I am pursuing B.Ed second year.
This video is for the students of 8th grade State Board of Maharashtra for subject Science. Hello all students. I hope you all are sound and well. You are having a good time at your home. But let's study now. Are you getting bored? Let's play some game. We can play game on a video with you and me. I like to play carrom board. Would you join with me? Oh, those are nice coins. Students, focus on the striker because we know that striker is the one which helps to put each coin in the goal. Focus carefully. It's my turn. I am going to play first. But you have to focus on the striker, the direction in which it moves. And that's a hit. Oh, I got a coin. So, have you observed the motion of striker? Where did it go? Did it go straight forward or it turned back? Think carefully and keep your answer in mind. Now, after some moves, my carrom board game had coins in this place. I always love to take a queen. We win the game once you get the queen. And see, there is an instruction for me. How can I get the queen? I am going to hit it. Please observe the striker carefully. Where did it go? Now, I am going to hit it. Oh, I missed it. So, where did your striker go? Think. Did it go forward? Or it got reversed? Or in some other direction? Think carefully and keep the answer in your mind. I'm missing those days when we were used to wander around. I'm recalling a few pictures from the outside world. Now, this is the one of the picture which is coming in my mind right now. Can you identify this picture? Yes, it's merry-go-round. Now, will you tell me what kind of motion does the merry-go-round have? Think how it's moving. Correct. I hope you got the answer that it moving in a circular direction around the center. That is also known as rotation. Correct. Okay. Now students, there are various games you can play while you are staying at the home. One of the game which I played with my family on WhatsApp that I will share with you. Now, we used to send the pictures to each other. And this is the one of the picture I sent to my parents. Do you know what is this picture is? Can you identify it? Yes, correct. It's a cake. Do you get something in mind from this cake? Okay, let us see. I sent them another picture. Who is he? And does he have something to do with that cake? Did he eat the cake or he had put some concept through it. So, there is in one way that man is related to the cake. His name is Sir J.J. Thomson. He was the second one who proposed the most fundamental idea about atomic model. So, will you be able to state the famous atomic model given by him? Take your time. You can pause the video and think for the answer. And you can resume the video when you are done. Now, let us see what did he say. He said, the atom is like a watermelon in which the seeds are like negatively charged electron and reddish part is like positively charged body. Do you see that in picture? Correct. And it is also famously known as plum pudding cake model. Yes, correct. Now I'm sure that you have got a pretty much good idea what we are going to learn today. Definitely, we are learning what is inside the atom. And now there are more people who are talking about it, who are discussing about it, and few of them are as following. First, Rutherford's nuclear model of atom. Second, the Bohr's stable atomic model. And third, atomic structure. This is what we are going to learn today. Let's have a look on the first picture. You know, as I told, the J.J. Thomson was the second person whose atomic theory worth to speak of. Now there were few others who were talking about it. The first person who spoke about it was Maharishi Kanad. After them, John Dalton in 1803 AD. He said the atoms are invisible, indestructible, very tiny, and that is made up, all masses are made up of it. I know you are recalling it somewhere in your mind. After him, J.J. Thomson in 1904. We just talked about it. Now, just 7 years after it, Rutherford came in 1911 with his famous model, which is scattering model. Let's look at the experiment he did and what are the equipments he used for his experiment. Observe closely. Can you identify this object? Can you tell me the name of most malleable metal that you know? Oh, do you know what is meant by malleable? You can Google it sometime. But today, I will also help you to know what is meant by malleable. And the most malleable substance is gold. What is meant by malleable? So, malleable means when you hammer any object so that it can be turned into a thin sheet. The Rutherford took a hammer and he kept hammering the gold foil unless and until it turned into a thin sheet. As you can see, how thin was it? It was 10 raised to minus 4 meter thick, like almost your hairs. Oh, I have less, but you must be having more. Now then he took radioactive material in hollow lid box. What is a radioactive material? These are the special material which can emit their own light. Then he took a curved mirror. Now you must be thinking of, oh, what is he gonna do with these all things? No, let me help you to know what he's going to do. The radioactive material have a special property of emitting alpha particles. It emits the alpha particles like a light emitting out of it. Now, you can see that's why he used a radioactive material, because he wanted to have those alpha particles. What he was going to do with those alpha particles? It was expected that from him that alpha particles which are positively charged in a nature must get repelled from the gold foil, as most of the part of a gold foil is made up of positive charge, as said by J.J. Thomson. And on experimenting the idea suggested by the J.J. Thomson, the results what he have received are something like this. Let us see the experimental setup. This is how Rutherford set it up the all equipments. Through that thin gap over there in the mirror, the alpha particles were allowed to bombard on a gold foil. Oh, he was expecting that there should not be any alpha particle which will be passed through the gold foil. And you and I also know that light do not pass through the gold. Yes, isn't it? But these alpha particles are special. He found that they were able to pass through the gold foil. But it wasn't just passing through, they were coming back as well. Are you looking at it? Are you able to find how many lines in a red color are coming back and how many lines are going ahead? Now, think carefully. What could have happened? What would he have found there? Was it the theory suggested by the J.J. Thomson was the correct one? Or it need to have some updates? Like you get the updates for your apps of Android every time. Like, so he thought there should be some update in the idea of the alpha particles and this atom and structure of atom. He said that as alpha particles are so tiny and as they are able to pass through the gold foil, that means there will be some empty spaces between the gold atoms. Then the particles which are moving in a straight direction, they were observed in different way. Like this one, few of them went through the atoms, but few other, as you can see, changed their direction. Few of them changed their direction by slightly, like the bottom line which is blinking in a blue color, but few other were deflected more than 30 degree. That is a great angle. Few were able to deflect more than 90 degree, like the one which is at the first, and others, like 1 in 20,000 particles of alpha, were repelled back from where it emitted, means where, towards the lead box. This is what he had observed through his experiment. That means not all particles were able to just come back, but few went through it and few scattered in other direction. That's why it is known as scattering experiment of Rutherford. Keep the name in mind, because they are scattering here and there. It's why it is known as scattering experiment. Now think and find, is there any suitable example which is coming in your mind? Okay, I will help you and I will give you one idea, but then you will have to find one for me. Are you ready? Okay, observe closely. Do you recall the experiment we did with the carom board? Ah, the striker. You have the answers in your mind, right? We had two questions. The striker either go through and get reverse. That depends upon whether it bombards on the other coin or not. But in here in our case, the alpha particles are behaving in a very same way as the striker from the carom board. Striker is not able to pass through the coins because coins are solid. In the very same way, if few alpha particles are coming back, that means there must be some solid part. But there is an equal possibility that the alpha particles which are not coming back, that means they are moving through the empty spaces as it had happened when I tried to take the red coin. Isn't it amazing? Now you can find one more example for me. Think. You can pause the video and take your time. Now let me tell you one example more. Look at the picture. So find any suitable example with help of which we can explain Rutherford's nuclear atomic model. These are the simple wooden fencing that is to protect our house from not to allowing animals from outside to come inside the house. Now let's have few stones and I am going to throw the stones on the fencing. Let us see what happens. Oh, I think I hit the plank and my stone got back. Let's try another one. Oh, it went through. So why the first one came back and why the second one went through? Because the first one hit to the solid thing and the second one went through the gaps between the fencings. And that is the similar thing happening with alpha particles in our Rutherford's nuclear atomic model. From that, Rutherford was able to derive few conclusions about the atomic model. Let us discuss them. The first conclusion was there is a positively charged nucleus at center of an atom. So, as we had seen in earlier picture, there was a reddish sphere at the center, and that is known as or called as nucleus. This is a new word, keep in mind. Almost the entire mass of the atom is concentrated in a nucleus because that was the only place from where alpha particles were coming back, right? So do you see, from most of the place, that is, see the circle, that is the how much the space that an atom have, and nucleus having just small portion of it, but entire mass is in just nucleus only. Now negatively charged particle called electron, which was suggested by Sir J.J. Thomson, right, revolves around the nucleus. He said that they must be revolving around the nucleus. You can memorize it like, or you can imagine it like moon moves around the earth or the planets move around the sun. It's somewhat similar but not the same. You can take it as an idea. Then next conclusion, he have found that the total negative charged on the electron is equal to positive charge on nucleus. As the opposite charges are balanced, the atom is electrically neutral. Now what does this mean? So let's see an example. This is a nucleus which is having a positive charge. This is an orbit on which the electron is moving, which is having a negative charge. Now, how many nucleus we have? 1. How many negative charge we have? That is also 1. Plus 1 and minus 1 results into, correct? And every time, whenever you do this, you get the answer 0 only. And that's how you get sure with atom is always electrically neutral. I hope you have understood. Now, will you be able to explain the difference between the distribution of a positive charges in Thomson's atomic model and Rutherford's atomic model? Correct. In Thomson's atomic model, the positively charged were spread throughout the atom. But here in Rutherford's experiment and it's in his atomic model, the positive charges are concentrated at one single place, not throughout the atom, and that place is used to know as nucleus. Now, after these all experiments, do you see this positive charge and negative charge? These are the opposite charges, isn't it? And we all know that opposite charges are always, correct, attracting to each other. Now, if they are attracting to each other, then why does this electron does not fall on the nucleus? Because if there is an attraction, it should be falling on it, right? So everybody asked Rutherford, why is this not happening? But suddenly that time he did not have any answer to give. If electrons were really falling like this to the nucleus, then each and every atom will not be called as a stable one. And as everything is made up of atom, every mass is made up of atom, then no mass will be stable because atom is itself unstable. But when you look around in your day-to-day life, everything is a solid and stable. That means electron must not be falling on the nucleus. Somehow it is remaining in the same direction where it is revolving. But what is the cause of it? He couldn't explain. Then here we have to think about a very important idea, like why is this not happening? Why this electron loses the energy and do not fall on the nucleus like you are observing in a picture? Someone else give the answer for it. The next person who gave a more important ideas about the structure of atom is Niels Bohr in just next 2 years, that is in 1913. Niels Bohr said that there must be one reason due to which electron must not be falling on the nucleus. And to explain his idea, he gave us 3 postulates. This is again a new word, postulate. What does it mean? This means we consider these activities or ideas are true, but only by observing, because suddenly we cannot prove it. Let us see what are those postulates given by the Bohrs. The first postulate, he said about the very question that had asked to the Rutherford. He said the electrons revolving around the atomic nucleus lie in the concentric circular orbit at the distance from the nucleus. So when I say concentric circles, means a circle with the same center. There can be multiple circles but drawn from the single center, and exactly on that center there is a nucleus which is positively charged, and electrons, correct, those are negatively charged. Then he gave the second postulate in which he explained the reason. The energy of electron is constant while it is in particular orbit. So the energy every electron have a different depend upon the orbit they are standing, and the every electron which are standing in a one single orbit having the equal energy, the electrons standing in a different orbits having different energy. Do you see? When you feel drowsy, less energetic, you move slow, like an electron from the orbit 2. But from the first orbit, they are dancing because they are having lots of energy in them. Now, the third and the last postulate, and the important one. He said that when an electron jumps from an inner orbit to an outer orbit, so see, from inner to outer, it absorbs the energy, like the light lines happened just a moment ago. Energy equals to the difference of energy level. As we see in previous slide, the energy 1 and energy 2 are the different energy which you have in these orbits. Orbits, what are those? These black lines are the imaginary lines which only demonstrate the path through which electron moves. The energy of inner orbit is higher than the energy of the outer orbit. Keep in mind. That's why if it wants to jump, it needs to absorb some energy, and when it jumps down, it releases it. It releases it in the form of light, and that is again, that released energy is again in an equal amount that had absorbed earlier, or equal to the gap between the two orbits. These are the three postulates which had given by the Bohrs, Niels Bohr, in 1913. Correct? Do not forget the year. Year of discovery is also equally important. Now, let's put these all different theories given by Dalton, Thomson, Rutherford, and Bohr, and let us try to see the picture of the atom which we are following today. So we are going to talk about the structure of atom. Atom is consist of nucleus, suggested by Rutherford. It is made up of two things, as suggested by Niels Bohr. He said that neutron and the proton together makes the nucleus. The protons are positively charged and the neutrons having a no charge, that is zero, null, chargeless, and together, like proton positively charged, neutron with a no charge, they comes together to make nucleus. Nucleus is the place where you have most of the mass of the atom. Then the charge on a neutron is 0 and the mass of a neutron is slightly more than the proton. Then it comes and orbits. The orbits are the path through which electron moves. Each orbit had labeled by Niels Bohr with alphabets starting from K, L, M, N and so on. In current picture, you may be looking at only 2 orbits, but there can be more orbits than this. Then last one is electrons. Now electrons have a negative charge, and electrons are lightest body having a less mass, smallest mass in the atom. Neutron, proton, electron, these three together called as subatomic particles. Even though the size and the mass of those subatomic particles are different, but still they keep the privacy of the other particles around them. Like electron do not leave the orbit, go and meet to the proton, because proton have its own privacy, as do the electron also. So they stay where they are. We shall keep the same attitude in our behavior, because we are also made up of atom, right? That is being gentle, polite and decent with others. Even if you see the protons are positively charged, electrons have a negative charge, still they stay side by side. They do not argue about their charges or their presence. Why? Because they are always feel like they are a team. Same way, you all work together as a team without thinking gender differences. I hope you got my point. So, what we have learned today? Today, we learned about Rutherford's nuclear model of atom through 3 different examples. Then Bohr's stable orbit atomic model and 3 postulates of it. Then the modern atomic structure with the 3 subparticles called neutron, proton and electron with neutral, positive and negative charges respectively. Name the particles used in the Rutherford scattering model. Which particle rotates around the nucleus? Who proved that atom is mostly empty? Watch the video again, find the answer and fill it in the Google form. The link is shared in description. Then there are a few more questions. Which subatomic particles are electrically charged? What will be the charge on the atom if it have 20 protons and 18 electrons? What is the thing which is present in Rutherford's atomic model but not present in Dalton's or Thomson's atomic model? Think carefully. And not to forget, mention your answer in the Google form shared by your teacher in a form of link. I know that you don't like the homeworks, right? But this is not a homework. In the days of this, you can do some activity at home. You can make a model of a structure of atom, which I have shown in previous picture given by Niels Bohr using household scrap. So you can use any scrap atoms. I hope you like the lecture, you like the session. If you have any doubt, watch the video again. Thank you everyone.